Before we get into the show, I wanted to put out a hiring call. I'm looking for my next software engineering apprentice, a young .NET programmer to help me directly with my work, building architectural prototypes, figuring out new patterns, tons of coding. And I'm looking for a .NET programmer whose hobby is also programming. For the right person, programming isn't work, it's play. And besides a job, I can guarantee that you will learn faster than you ever have before. And I will invest in your professional education and we'll work together and you will grow. You'll report directly to me. So if any of this sounds interesting to you, just send me an email or give me a call. Now, let's get into our show. Cloud Native and Serverless in Azure with Paul Yuknewicz.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, and they're a software engineering firm that serve companies that absolutely need delivery of software projects critical to the business. And when failure is not an option, ClearMeasure guarantees your success. And you can find them at clearmeasure.com. Quick announcement, we are in the second year of my architect forums. Signups for the new session are up for February. If you lead a software team, if you're a lead engineer, a lead architect, and you're looking to collaborate with peer architect leaders, just sign up at the link in the show notes. We understand there's tons of learning resources out there for how to learn how to code and how to be a developer, but not so much for how to lead a team of developers. And so we enjoy doing that. And for those who are looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. Now, my returning guest today on the show is Paul Yuknewicz. And he was on the show way back in episode 136, and we're at 284 right now. And he's a lead product manager for the Azure Developer Experience team at Microsoft. And he's responsible for the PM team that designs the developer experience for building and diagnosing cloud native applications for Azure. And in this role, he's just super passionate about helping developers succeed when they're building high scale distributed applications. And he loves having a strong collaboration with customers. He also has fun learning and challenging the status quo in a breadth of technologies and languages like Linux, Windows, Java, .NET, serverless, containers, service meshes, application observability, and all kinds of things. And he speaks at industry conferences too, not just the Microsoft conferences, but also conferences like DEVIntersection and TechBash and more. And we're going to include his Twitter and other links in the show notes. But Paul, welcome back to the show. How are you, sir?
Hey, Jeffrey. Thanks so much for having me back. I'm doing great. It's been a while, so I'm so glad you invited me back to your podcast.
It has. It's like right at the end of the COVID year or the next spring, everything.
Yeah, the world feels like a different place. Yeah, it's good.
Right.
This is a good catch up.
Well, just to I want to dive right into serverless, but backing up a little bit because there's been plenty of people that have heard you speak at a conference or seen some of the online sessions and the recordings and whatnot. But we get more new and new developers every day. But for those who haven't heard you speak and getting acquainted with your work, are there any big sea changes in your career that you look back and say, man, I'm working at Microsoft on high tech, cloud technology and events that kind of steered you in this direction that you remember?
Yeah, that's great. So from the very beginning of my career here when I started, so that was back in 2000. I can count the years just by, minus 2000. So that's how I remember. So there, that was .com. And so that was kind of like before there was cloud, we thought of the web and we thought of the .coms. And I spent a lot of my career working on dev tools, dev experience, SDKs. I know a lot of Visual Studio and .NET developers listen to the show. So I worked on like ADO.NET data sets, the data tooling, and also the web tooling. And I think that's where I got the itch of I still really love working on code, working with developers, and trying to, doing cool things and making it easier. So I got that developer itch then. And then the next big inflection point, I think for me, was SharePoint. I mean, SharePoint was like the best web app ever made at the time. I mean, you had to love GWIDs just a little bit, but fantastic application platform. It was so much more than kind of CMS. And so I got to work with that, and that was really eye-opening. And then Azure really kind of came into be. So I started working on Azure back when our main service, it was a PaaS service, but it was called Cloud Service. I don't know if you all remember that one. So it had web and worker roles. And it was kind of a cross between a VM and a managed, thing. And that kind of brought you into stateless programming, like big time, and offloading your state and scaling. So that was a big point for me, for sure. Then I kind of combined the two worlds. So I worked on tools, but for Azure, and SDKs, but for Azure. Fast forward a bit, I got a really fun break to work more in the microservices field by helping the Dapper project. I don't know if you know Dapper. So it's for microservice developers. It's a framework and runtime that makes it easy to do important things like pub sub, observability, having resiliency. So,
and that's DAPR, right? Not to be confused with the micro
right.
ORM.
Yes, there's so many good Dappers. I guess when you imitate something, you really love it, right? So Dapper in this case stands for Distributed Application Runtime, and so it's just DAPR. So Dapper is kind of cool because the team that founded it, they started working on Service Fabric, and I don't know how many folks know Service Fabric. That was is a fantastic platform for microservices, and it's a big, powerful platform. And the folks working on Dapper, decided to say, okay, let's take our favorite pieces of this, but let's open it up to the whole universe. Let's make sure that this can run on any cloud, any platform, Windows, Linux, with any language you want for your SDKs, like JavaScript or Python, .NET, Go. Let's make sure it works in managed services and in Kubernetes. So it was kind of like inspired by the capabilities of Service Fabric, but done in a form factor that I think was more immediately adoptable for just a lot more people. And so I got that was an incubation, and we had an ambition to make that kind of a real project in the CNCF, and then also really productize it in Azure. So I got pulled in to help with that. And I eventually came to lead that from the side. And we took it to graduation in CNCF, which was, or not to graduation, I apologize, to incubation status. We're working on graduation now. And I really learned a lot more about the open source world and how powerful and kind of important that can be. And I brushed up and learned a lot about how to write a distributed app that scales and use microservices. I mean, we don't want to use it everywhere, but I learned where it could be effective and how to do it, and what some of the big problems are. I guess is my super long-winded journey, Jeffrey. Sorry, but yeah, that brought me to serverless. So now I work on serverless. And you can think of serverless, it's like instead of having actual VMs, actual machines, it's all about, you pay for the time you're using compute. You don't really think about instances anymore. You just think about executions and what you're trying to do, and off you go. And so we, in Azure and in Microsoft, we have at least two main ways to do this. We have Azure Functions, which is really like the tiniest way to have a piece of code or event-driven code and to be able to scale that out. And we also have container apps. And container apps is good for a lot of reasons, but it, if you love container-style development, the unit of deployment is a container. Also, for different kind of workload profiles, sometimes you don't have these short-lived event-driven codes. You have something more like a server, or you need the platform itself to be less opinionated about what's running. Like Functions is very opinionated. If you want to do event-driven or simple APIs, it's absolutely fantastic. But if you want to have other kinds of, like a daemon or a server, might not be the best way to do that.
That's always running.
So always running. So it opens up that other avenue, but it still can, like we call it, scale to zero. You can still kind of say, hey, when there's no usage, you're not paying. Like you're not, the servers are all released and you don't have to worry about it. So both of those are serverless functions and container apps, and I think it's got a close cousin in Azure Kubernetes service where you might be running similar kinds of workloads, but you're getting a lot more control. So you can always kind of say, hey, do I want more serverless and I want the cloud to manage these resources for me? And that's not what I want to work on. I want to focus on my app. Or you could say, no, I want a lot more operational control. And then there's Kubernetes. So that's the universe that I've been in. I guess those were some of the major changes throughout my life. And now we're in the era of AI, and we are very involved in that. We're using AI for our own work, generative AI and things like that. We're also, even diagnostics, let's say, like we analyze and reason over better insights that we can give to customers using OpenAI. And at the same time, we also try to be an easy way to get started and build apps that use AI. Maybe not for the data scientist, but for an app developer, hey, I want to do RAG, which is, basically chatting and generating content from your own data. Or I want to do chatbots. We want to make that incredibly easy to add to any current application. So that's also something my team's working on. Very exciting.
Yeah, there's a lot of stuff.
A lot of stuff.
I want to ask you about so much stuff, but before we get into that, I want to maybe define some terms and see how you think about some certain concepts that people wrestle with. You guys are always on the cutting edge on, how should developers work better and what should developers use next year? And then all the developers are like using, okay, what's available now, or what was available when we started this project or started this system, a few years ago and whatnot. And so there's two concepts. And I think a lot of people struggle with the difference between them. How do you think and separate the differences in the concept of serverless versus someone that says, I want to develop this in a microservices fashion? But I see some people get conflating the two or saying, okay, if you use microservices, then you have to use X, Y, and Z to deploy it. How do you keep those concepts separate?
Yeah, that's a really good one. And I think, by the way, they can go together quite well, but I see them as distinctly different too. Maybe let me talk about microservices too, because right now in my head, I feel like I can explain that better. And then I'll make my way to serverless. So microservices to me, it's in a word, it's about agility. It's about, I want to work in teams on smaller pieces of code that are meant to work autonomously. And they can also scale really well because you have a smaller service. You can scale it out, meaning you could have 1, you could have 10, you could have 100, you could have 1,000,000 instances of those microservices. And you scale by doing things in parallel, right? You kind of load level across multiple instances of your microservice. And your microservice knows how to do that one small job really, really well. And then when you're building a distributed system, if you can think about places where your organization or your deployment or even your scale is going to differ, that helps you draw out, well, those are the microservices I probably want to have. I want to be able to ship a microservice as one unit independently and not have one team kind of be waiting all the time for another team, when things are tied together. So you get that independent deployment, and then you get independent, we call it horizontal scale, so that each of those pieces can scale out independently. We all love to blame the database, but for example, there could be very different, like if your workload is CPU intensive, if it's IO intensive, there's different bottlenecks, and you can really kind of say, hey, here's a place that's been a bottleneck in my app, but I can give it many more resources and many more instances to throw at just that one part of the problem. And you can really improve your app. So I think microservices is good for that. It's like a way to refactor and work. And, it's not that different. Like you and I have been around for a bit, right? And we've talked about like N tier, logical N tier, physical N tier. Sorry, here I'm bringing back the memories. But it's not, I mean, we knew how to think about the problem then. I think it's just evolved a bit more of like, you can make things even smaller with an attention to more scale and more agility. So that's microservices. Now, microservices it's like a philosophy and a pattern in my head. It's not telling you a particular implementation. I mean, there's a lot of experts out there who'll say, okay, now here's how you do it. But you can do microservices almost with any technology. You can follow that pattern today. But then if you think about that unit of deployment, there are technologies that work super well with microservices because they're kind of meant to be small. They're meant to come and go fast. And that's why I think of containers are great, because when you want to deploy and have a lot of density of microservices or a lot of density of instances, containers are an awesome way to deploy and kind of also protect you from yourself with your dependencies. And then serverless, I think serverless is the next magic thing of like, hey, I don't want to be managing partitioning of virtual machines or servers to think hard about my workload and how it's going to consume resources. Just the serverless idea is just let me use what I need to use for my workload, let the scale go up, let the scale go down, and I'm only going to pay for what I use. And so I think that's another very complementary thing, because if you have a microservice architecture, you have the ability for the app to scale like crazy. And it could be like, I call it a burst, right? Mm-hmm. So if I'm a retail person and it's Black Friday, I'm expecting a huge burst, but I don't want to go buy a whole bunch of servers. I want to go add 20,000 more servers just to be ready for a day, mm-hmm. right? So you want to have that burst scale where it's like on demand, you scale out, and then you scale back, off peak. And not everything's as crazy as Black Friday. That's like the easy one to go to. But I think a lot of workloads are, they have peaks and off peaks, right? If you're writing the IoT app for a car, people like go to work at a certain time, they come home at a certain time, and in every geography in every country, it differs, but it's kind of predictable, right? You have mm-hmm. these peaks and off peaks, and serverless is also good for that because it lets you really get even more optimized and kind of do more with less. Like, okay, if there's not a lot of traffic, if there's not a lot of users, there's no point having all these warm servers that I'm paying for.
Right.
So serverless gives you that kind of economy, and you don't have to think about it. You let Microsoft do the work you would have done yourself to kind of manage a pool of servers and mm-hmm. Provision them the right way, and to do all the banking, to think about how much you need that quarter, to depreciate them over time. You let us deal with all that junk. So that's how I think about it. I think it goes together. Hopefully I explained it kind of okay. It's maybe another way to say it's serverless is a fantastic scaling engine. It knows how to scale very well, and it's self-updating, self-healing, which is a nice complement to microservices. But you can run microservices on a VM. You absolutely can.
True. That's true.
And you could even save money if you really know what you're doing and you want to work hard.
Yeah, and you're okay with some number of 9s of uptime, and you don't need the upper echelon.
Some number. It's all trade-offs, right? Yeah, but right. I think if it's like you don't want to, if operational control and having a large operations muscle in your team is not what you're looking for right now, serverless is good for that. Mm-hmm. If you have those skills, then maybe serverless is overkill, right? Like maybe you've got. So I think just it depends on what you want and need.
Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
I mean, you talk to so many customers, huge, large enterprise customers, and I'm on the consulting side, and in my world, it's almost like 1 in 10 software systems, 1 in 10 projects needs to have that non-deterministic scale factor where, okay, we may get hit, we don't really know when, but our infrastructure, we just need it to be elastic and respond. But then the other 9, they know exactly what their peaks are, and it's not going to surprise them. But they ask, okay, but I don't want to have that level of infrastructure up 24/7. How can we pull back down and have it elastic for a cost savings perspective. And I mean, the serverless will shoot even app service and Azure databases, SQL databases, and container apps and functions. I mean, it works going that direction too really well.
Yeah, it sure does. Yeah, it works for your backend services. It works for the compute. Again, as much as we like to blame the database, it's not always the issue. I really agree. I think that's a great way to think about it. This one isn't public yet, but I've been working with a very large auto company. You could probably look out the window and see one of their products. And they had a huge footprint, tens of thousands of VMs, always warm, to service their car to cloud kind of app. And they're very good at it. They're very efficient. Like they really pack the workloads correctly and place them. But it kind of like there's two kinds of costs. One is like you said, keeping those servers always up and paying for the uptime. That really adds up. And when you're having, when it's 3 a.m. and your customers don't need it, it's kind of wasteful, right?
Yeah.
And then also there's the operations side, which a lot of times we don't always think about the cost, but you have, high salary people wrestling all the time just patching those things. And like literally for that customer, they have 2 dedicated people who are fantastic engineers, but they're not excited because they're like spending a bunch of time just patching the operating system, which, after a while is maybe not what you want to be doing. So that's a thing. I mean, don't hold me to it, but they moved to a serverless model, just happen to be functions, but they're saving about 50 to 60% just by recognizing that off peak, I can scale some parts of the app way down. I can even scale it to 0.
Yeah.
And also because their operational headache is just a lot lower. So they really see a savings. And I think, with the economy and everything, it's just a good time to be thinking about if I have a workload like that, I can save. But if I want something always ready and warm and, and I'm paying for that performance, maybe that's not what I want. So there's really good cases for it and there's less good cases for it.
Yeah. Yeah. Well, speaking of that, you guys went GA with Azure Container Apps. What was it, last May or June, sometime around there? And so it's kind of it's been out there for a while. Lots of people are using it, and Kubernetes under the covers, but it's got really nice Azure tooling at the top level when you don't just need to turn all those knobs. And in my experience, like 9 out of 10 applications, you don't need all the Kubernetes knobs. You can just kind of keep it at a higher level. And so Dapper, it's kind of like a first-class citizen. It's part of Azure Container Apps. It's right there on the side menu when you look at Azure Portal. Help us understand the architecture of Dapper. It's with every container app, but is it meant to live beside every container, every Azure Container App instance, a grouping of container apps for a larger system with maybe 10 processes running or 10 containers? What's the intended structure for that? That's
an awesome question. One of the deeper questions anyone's asked me on Dapper. Thank you. So so first of all, Container Apps is a serverless platform, and it's kind of like, cluster style computing, and you have workloads living within it, your apps. And in an app, in the Container App case, each container is its own app. It's kind of like it could be the scope of a microservice or one backend API. And you're going to have multiple apps, oftentimes, that communicate to each other, whether it's over HTTP or gRPC or maybe using messaging, like a pub sub. So a lot of times these things are connected and they're not just standing on their own. They can stand on their own. And so if you think about, first, let's think about that's the world that is Container Apps. So Container Apps, like you said, it abstracts the operations over a Kubernetes cluster and a Kubernetes control plane. But that control plane is actually there. So the capabilities that you want, like, hey, I can partition workloads in pods and I can independently scale pods. That concept is there underneath, but it's exposed in a more friendly way where we call them apps. And the apps can scale to, from 0 to n instances, and they have scalers, so they can watch your traffic and they can watch your queue depth and things like that, and understand, here's how many instances I need now, and that's dynamic. It changes over time. So that's kind of like the first part. And then the second part with Dapper, by default, we guide people to create one Dapper sidecar for each application.
For each Azure container app?
Yes. So for each container app, or for each microservice, let's think, or for each process,
for each deployed
you'd have a sidecar. You can get more efficient. You actually can share sidecars. There's absolutely nothing wrong with that, but it's allowing you to have a little scalability of your control plane along with the application. And let me talk just a second more. So Dapper is exposing you APIs like I can publish via PubSub, or I can do state management by using the state API, or I can just make an HTTP call with invoke, and I'm going to get service discovery. So it's got these just simple different APIs, really simple, but they're exposed to the system through a sidecar process. Now, I don't necessarily mean a sidecar container. It's just another exe that's running. It's like a server that's on your local machine. And that way, your local application can always find those APIs, and they don't need a connection string to somewhere else, some server, some cloud. They're just literally talking to Dapper. And that's providing that level of abstraction. Now, Dapper gets configured to work with the actual backends you want to work with. So if I'm doing PubSub, I can back it with a service bus. I can back it with event hubs. I could back it even with Kafka, like open source. So however you configure it, the SDK and the programming experience of Dapper is the same. It's the same API and abstraction implementation it's exposing to the developer, and it gets reconfigured underneath. So the sidecar, it's kind of an ambassador pattern. If you're a patterns nut, it lets you, have the level of abstraction and a facade, and then underneath it handles the right provider implementation for you. So so the sidecars are important because it gives you the APIs, and it also understands the identity of your application. So like if I have an order processing microservice and I have a job cart microservice, when they start up, the name and the identity of that app is known. And that way the sidecars can communicate and they can find the other applications. And it's like everything goes through a sidecar, also a little bit like a service mesh, which gives you additional observability. It gives you better DevOps and things like that too. So the sidecar is kind of an important piece. So basically what you would do for each app, for each container app, for each microservice, you deploy the code just the way you always do with a container, any language, and then you say enable Dapper. When you enable Dapper on that container, what it's actually doing is creating the sidecar for you. And the Azure Container App Service is managing and orchestrating. It's like spawning those sidecars and despawning them for you, so you don't have to think about it all. You just said checkbox, enable Dapper. And then the other part of it is that Dapper configuration says like, hey, what service connections do I want to have? Is it Kafka? Is it Service Bus? And what's really happening underneath is Container Apps is configuring the Dapper sidecar dynamically to be aware of those backends. And it's setting up the network, because like the networking for Container Apps happens to be Envoy. So it's also helping Envoy understand all the routing and all the networking so that like your mesh, so to speak, of your distributed app can find all the parts. I'll take a breath. I don't know if I answered what you wanted.
Is Dapper literally running inside my deployed container?
It is not. It is. So first of all, Dapper runs as a sidecar executable. Like if you're on your local machine and you spin up a .NET app, you'd say like .NET run. You would also you would do a Dapper run, and it would spin up the sidecar. And think of it that way. It's like it's spinning up a separate server that exposes those APIs to you.
If Azure Container Apps is a Kubernetes pod, and if I'm thinking about that, and my container image that I deploy spins up a running container of my container, the Dapper process is running. Is it running in a separate container in that same pod?
Exactly right. Yes, It's a separate container, because usually you have a one-to-one of containers and processes, but then you organize them in pods, so it's the same scaling unit.
Okay.
So yeah, you get more application instances. You get more Dapper instances too, and all that orchestration's done for you, which is a nice thing.
So in the boring case, let's say I have 10 container images, each with just this back-end service that just watches queues and just sits there and crunches data. And some of those services need to send to another queue, or maybe call a web service endpoint of another queue. Normally, I would deploy it with some configuration with the network address, or if I set up CNAMEs or DNS to go to that other one. So how do I configure? I understand it's different. What is the tactical process of asking Dapper, hey, give me the DNS name and port so that I can find, service B?
Yes. So Dapper really abstracts that away from you. So as the user experience as a developer, most commonly, and I'm a .NET person at heart too. That's how I learned. I would grab the SDK for Dapper. So it's called just the Dapper client.
So just a NuGet
So I'm
package.
using the SDK as a NuGet. And I literally just start writing code against the client. I would say client.publish. I would take my POCO object and I would name the topic that I want to publish it to, and I just publish. There was no client constructor or factory where I'm passing in a connection string and all that kind of stuff like you're describing. There isn't that. Because what Dapper is going to do is it's just going to be like, okay, I'm calling the PubSub API. I'm going to leave it up to Dapper to fulfill my dependencies for me. So the only thing the Dapper SDK had to do was find its sidecar. And that's what our service does. It helps place the Dapper sidecar on the network in a well-known place using the environment variable that we set for you, that it will always find that sidecar. So it's literally, instead of calling a TCP or HTTP address, it's literally like localhost port 3500 and then /API/publish.
Yeah.
It's always the same URL. It's always the same credentials to the sidecar. And then the sidecar is where that heavy lifting is done. It's basically like the service connector to the actual backend. So that guy gets configured with managed identity or a connection string to the actual message broker, the actual database, the actual state store.
So if I have 10 parts to my application, 10 deployed processes, package each one of them in their own container image. I've got 10 container apps in my resource group. Each one of them gets one container image. They're all spinning up. I'm guessing I need to give each one a constant name to refer to it. I mean, yes, I have to have something, right?
Just to identify
an identifier.
Just to clarify what you mean. So you give each service a name, which oftentimes is like the CNAME or the DNS name, right? You're just like, hey, this is the orders service.
I could literally just call it order service, purchasing service, charge credit card service.
Exactly.
Okay.
Exactly. And then, Dapper has a concept of a component or a resource. So you're just saying, I'm using my orders PubSub. You just refer to it by name. In your coding, that's all you do. So it's kind of like, what did we call this back in the day? Aliasing. It's always an aliased kind of a thing. I'm just calling something by name because I know what's backing that name can change all the time. And it has to for operations reasons.
Yeah.
And then the Dapper sidecar, it's the mediator. It's like, when Jeffrey asked me for the orders PubSub, I know exactly the PubSub broker instance that we're going to point to.
Okay.
But your code is shielded. You take all that configuration gunk out of your code, and it's just an operational concern on the sidecar now.
Well, final question as we kind of wrap up.
Yeah.
Because this is I'm personally excited about this next era and being able to deploy. But all right, I've got these 10 containers running around just by a name. They're finding each other. One spins up and they're broadcasting, hey, I'm the charge credit card service. I'm online. You can find me. All right. But I got an Azure subscription. I've got maybe multiple software systems. And how do I know that I'm looking for the charge credit card service of a particular software service and not a name or a name collision with some other software system that I may deploy in this Azure subscription or resource group? Or do you have a recommended segmentation of only one system per,
There's different ways to scope it. And I feel like you're almost I'll geek out. You're almost talking about an east-west situation where an internal app in this cluster over here can talk to another internal app over here. So by default, Dapper is configured. If you like to think as a cluster, it's all the services are known and unique within a cluster. In container apps terms, we call that a container apps environment. So you create one container apps environment. By default,
that's the ACE.
Every application can know and find and discover other applications, and we won't even let you get into a collision. When you try to deploy a collision, you'll get an early panic that, hey, you shouldn't do that, dude.
Okay. Makes sense.
And so it works in that way. Now, if you want to do more of the east-west, where like regions are talking to regions or things like that, you can do it, but you're probably going to want to use another piece of networking technology, like a mesh gateway or some kind of a gateway that is disambiguating, like when traffic goes to east-west, which node you're talking to.
Yeah.
So it's another level of abstraction that I see customers actually do for that.
Okay. So then,
so within your cluster, which is probably a lot of what we see people do, it's like, pieces of my app can talk to each other.
Yeah.
That works by default, and I don't think there's much risk of collision. East-west is like, that's sort of another thing.
Yeah,
You've got to set up a mesh gateway or something like that.
And the Azure container environment, is that the exact parallel with the Kubernetes cluster?
Exactly right.
Okay.
At least that's the way I think about it.
Right.
Yep.
And so if I'm setting up, I don't know, multiple test environments, then the guidance or the architecture, the intended architecture is every separate environment should be in a separate Azure container environment so that you get that scoping. Even if I need...
that gives you that scoping.
Yeah.
Now, if you need to, there still might be some reasons where like, hey, I want something to be kind of fenced and shielded by default, but very special services should have access to it on the network. You can also do that by you deploy to the same environment, container apps environment, but we have a feature called scopes where you can further say, hey, the scope of this service is only these two other services get to call it. That's it. These two like specially granted. So you get it. Okay. There's basically app level security and app level networking, even on top of the default cluster networking that you can impose. Again, it makes it easy. We don't want devs to have to know everything about operations. It's kind of like, I just want to say these apps can talk to these apps, but not these other apps. You define it in a policy, you're done. And Dapper takes care of that for you.
Nice.
Nice. And then you get the sandboxing.
Well, this is a lot of good detailed information. I've seen and heard talks on serverless and Azure Container Apps and even played around with it itself. But coming from someone who's literally on the team, like you've been in those architectural meetings with debates. How should we do this? No, let's do it this way. No, let's do it that way. So getting the actual architectural intention, behind those decisions is really, really valuable. I appreciate you sharing.
Oh, thanks. And we've, honestly, we've grown, we've learned a lot operating it over time. So, I'll be honest with you too. We've had ideas that haven't panned out or they haven't scaled as well. We've had to redo them. But I think we're getting there. We're getting better at this stuff.
Nice. Well, hey, I appreciate you coming back on the podcast and sharing with us the kind of the latest in serverless on Azure. That's awesome. Thanks for coming.
Hey, anytime. Thank you. It was really fun to chat about that. Like I said, I don't think I've ever gotten to talk about these like specific aspects. That was really fun.
Awesome. Thanks so much. And listener, until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.